In this problem, we're told the length of a rectangle is 8 inches less than twice the width. If the area of the rectangle is 90 square inches, find the width of the rectangle. So in any of these kind of problems that deal with geometric figures, I like to do a rough sketch. Notice I said sketch, that is meant to look like a rectangle. It's as close as mine get. I know that the area is 90 square inches. Whoops, excuse the bad handwriting. This is the length and this is the width. And to find the area of the rectangle, I know area is L times W, length times width. We know the area is 90, so I have 90 equals L times W. But unfortunately, on the right-hand side, I have two variables. I only want one. So we're going to have to use this first sentence to describe the length in terms of the width. So looking at it, I have the length of a rectangle is, so that translates to L equals 8 inches less than twice the width. Directly you see this less than, you should have alarm bells going off saying, be careful. This is one that students mess up a whole lot. They tend to translate it exactly in the order it's written. So they write 8 minus 2W. That is wrong. If I want 8 inches less than twice the width, I have to start out with twice the width, 2W, and subtract 8 from it. So be very careful with anything that says less than. So now all I have to do is substitute this into this equation for L. So I'm going to get 90 equals L is 2W minus 8 times W. So now let's simplify this. I get 90 equals, distribute in the W, 2W times W is 2W squared, and W times negative 8 is negative 8W. So what kind of equation is this? Notice the highest power on the x is a 2. It's a quadratic equation. So I want everything on one side, 0 on the other. So do I have 0 on this side? No. So that's the first thing I want to do is subtract 90 from both sides. So I get 0 equals 2W squared minus 8W minus 90. So now I have everything in descending order on the right-hand side, 0 on the left. I'm going to try and factor, and if it won't factor, I'll use the quadratic formula. So what's the first thing we do with any factoring problem is there a greatest common factor? Yes, I think all my numbers are divisible by 2, so I'm going to factor a 2 out. So I get 2 times W squared, 2 goes into 8, so I'm going to get minus 4W, minus 2 goes into 90, 45 times. So now two things multiply together equaling 0. One of them has to be 0. So can 0 equal 2? No. So I know that W squared minus 4W minus 45 has to equal 0. So comparing that very quickly to AW squared plus BW plus C, in our case we know that A is the coefficient of the W squared is 1. B is the coefficient of the W, which is negative 4, and C is the constant term, which is negative 45. So I need two numbers that multiply to A times C. A times C, 1 times negative 45 is negative 45, and they need to add to B, which is negative 4. I'm just going to put it on pause for a second. Since they multiply to a negative, the signs are different. Since they add to a negative, the bigger number has to be the negative one. Well, these two didn't work, these two, but 5 times negative 9 is negative 45, and 5 plus negative 9 is a negative 4, which is what I'm looking for. And since A was 1, these are my two factors. So now I know that I have W plus 5 times W minus 9. Those are my two factors. Multiplied together equals 0. So you set each of them equal to 0. So W plus 5 equals 0. W minus 9 equals 0. Subtract 5 from both sides. W equals negative 5. Add 9 to both sides of this equation. W equals positive 9. Well, is it possible for the width of a rectangle to have a negative 5 width? No, so that is not a good solution. So I know W equals 9. What are my units? Inches. So W equals 9 inches. And is that all they asked me to find? We had to find the width of the rectangle. Notice they didn't ask us to find the length as well. So we have finished the problem. But if they'd asked you to find the length, all you would have done is go up to this equation for the length and plug W equals 9 into here.